So I want you to consider a particle moving along a straight line. And I've given something about its velocity. And remember, the velocity is a derivative or rate of change of a position function. Now, I want you to make a distinction between determine the displacement of such a particle from beginning to end of the time period and total distance traveled by the particle from beginning to end of the time period. So my picture may not be accurate. I didn't do any computations. When t is equal to -2, I don't know what the position is. I just call it S of t equals -2. But notice how that trinomial for the velocity factors nicely. So at t equals -1 and +2, I change from positive to negative for velocity. Well, outside -1 and 2, velocity is positive. Inside -1 and 2 is negative. So outside -1 and 2, I'm moving to the right. On this side, I'm moving to the left, and then move to the right again. Now, I want you to talk about displacement between t equals -2 and t equals 3. That would be the difference between these two positions. And so you merely get that displacement can be interpreted as the evaluation of the integral involving velocity with respect to time t from -2 to 3. But I think the difference in these positions does not represent how much distance traveled, because I think the distance traveled should be the distance from t equals -2 to t equals 1, or excuse me, -1, plus the distance which is a given positive or non-negative number covering that distance. Given that I'm moving in the backwards direction, I should subtract that integral and then add from 2 on up. In other words, what I'm really trying to say is this. To compute the total distance traveled, I think we should look at the integral from -2 to 3 of the absolute value of v of t. And excuse me, my goodness. Now, in my particular example, displacement is merely this. If you don't mind, I won't waste your time by evaluating this integral by anti-differentiating term by term and finishing up with the second fundamental of theorem of calculus. But look at this one. The distance traveled, since I got the absolute values in here, I think should be split up from t equals -2 to when I change from increasing to decreasing. And then add to that the negative of the integral from -1 to 2 when the velocity is negative to make it positive as a distance traveled. And add to that from, I don't know, is it 2 to 3? Here too, I don't want to spend 10 minutes just evaluating each of these integrals, adding these values together. I don't think that would be useful for time. So I'll leave it to you to evaluate this number right here, and then this number right here. Displacement, total distance traveled, over the time period from A to B, or in this case, is at -2 to +3.